Hello everyone. Today we're going to be going over slopes of parallel and perpendicular lines. So first up, a bit of a brain warm-up. So the lines here are parallel. What do you think is true of their slopes? So remember from last time, slope measures steepness, and all three of these lines seem to have the same steepness. So therefore it seems reasonable to think that the slopes must be the same as well. So let's check that. So a couple different lines here, L1, L2, and L3. Remember, we can determine the slope of a line by using the formula y2 minus y1 over x2 minus x1. So for L1, we've got a point here. Coordinates are 1, 4, and the coordinates of this point are negative 5, 2, negative 5, 2. So this would be your x2, y2, and this would be your x1, y1. And just plug in the numbers into the formula here. So y2 is 4, y1 is 2, x2 is 1, and x1 is negative 5. So in the top we have 4 minus 2, which is 2, and 1 subtract negative 5. So that's the same as 1 plus 5, which would be 6. So the result there would be 1/3. Hopefully you can see that still. L2, similar procedure. We've got 2 points here. The coordinates of each. This one looks to be 0, 1. This is at negative 3, 0. So we've got y2, y1, x2, and x1. So y2 is 1, y1 is 0, x2 is 0, and x1 is negative 3. Result on the top is 1, and 0 subtract negative 3 is the same as just adding 3. So if you add 3 to 0, that's positive 3. And last one, L3, coordinates are 2, 0, and negative 7, negative 4. Right, we go left 7, down 4. There we go. So plug in your y2, y1, x2, x1. So y2 is 0, y1 is negative 4, x2 is 2, and x1 is negative 7. So negative 4, so subtract negative 4 is like adding 4, and 2 subtract negative 7 is like 2 plus 7. Does that work? Oh, what did I do here? Say 3. Did I do something wrong here? I'm sure you're probably screaming at your computer right now. So let's just double check. 2, 0, so 0 subtract, oh, there it is. Whoops, that should be negative 3, so negative 7, negative 3, my apologies. So that should be then negative 3 there. I thought something looked a bit off, so that shouldn't be a 4. That should be just a positive 3. And to subtract negative 7 is 9. 3 over 9 reduces to 1/3. That's better. So now it looks like all three slopes are 1/3. So looks to be true that the slopes of parallel lines are the same. Okay, moving on. The following lines are perpendicular. What do you think is true of their slopes? So we know that parallel slopes are the same. Perpendicular slopes, I don't know exactly how they'll be related, but I suspect they'd be different. How different? I guess we'll find out. So is there a way that we can tell whether or not they are exactly perpendicular? And you may have guessed that there is, otherwise I probably wouldn't have asked that question. But yeah, we're about to find out how we can tell whether two lines are precisely perpendicular. So let's look at a couple examples. We have a couple of perpendicular lines here, L1 and L2. The slope of L1 will need these two coordinates, so I'll try to get these right this time. 1, 7. Yeah. This would be 0, 4. So, okay, hopefully I got those. So let's just do the slope of L1 first. So we do 7 subtract 4. That's y2 minus y1. And x2 minus x1 will be 1 subtract 0. 7 minus 4 is 3. 1 minus 0 is 1. So I guess we have 3 over 1. Did I do something wrong again? 1, 7. Oh, I see. That should have been bad luck. Sorry about that. It seems like this is the y-axis along here, so this would in fact be negative 1, 4. So my mistake. So we'll just fix that on the bottom. So rather than a 0 there, it will be negative 1. So that means that rather than a 1 on the bottom, we have a 2. Okay. So there we go. All right, next one. And I'm going to try to be really meticulous with this. So we got 2, 0 there. And that's the origin, so we need to go 1, 2, 3, 4 to the left and 4 up. So negative 4, 4. And now we're going to calculate the slope of L2. So 0 subtract 4 divided by 2 subtract negative 4. So 0 subtract 4 is negative 4, and 2 subtract negative 4 is like 2 plus 4, so that would be 6. So negative 4 over 6, that reduces to negative 2/3. Okay, so you can see maybe we've got a little bit of relationship there. It just looks like we've got a 2 and a 3, right, in the fraction. They're flipped. And we also have this negative sign for L2. So it seems like we might have a pattern developing. That might just be a one-off though, so let's maybe just see how this next one works. So starting with the slope of L1, okay, that's 1, 6 there. And this, I'm just going to be really careful, that's the origin. Left 1 down 2, so negative 1, negative 2. So slope of L1 would be 6, subtract negative 2, so 6 is y2, negative 2 is y1, divided by x2, which is 1, minus x1, which is negative 1. So 6 subtract negative 2 is 8. And 1 subtract negative 1 is 2. 8 over 2 reduces to 4. Just 4. We could write 4 over 1. Maybe just to see if it links up with previous example. Okay, so L2, we need this coordinate, so that's 2, 2, right? 2, 2, and this one is negative 2, 3. So slope there, y2 is 2, y1 is 3, x2 is 2, and x1 is negative 2. 2 subtract 3 in the top is negative 1, and 2 subtract negative 2 is like 2 plus 2, so that's 4, and there we have it. So it looks like we have 4 over 1 here and negative 1 over 4. So what can we conclude about the slopes of perpendicular lines? the negative reciprocal. So the negative reciprocal of a line slope gives us the slope of a perpendicular line. Perpendicular line. Okay, so basically, so reciprocal is just a fancy way of saying you flip the numbers in the fraction and you put a negative in front of it. So if I give you a slope of 3/2, the perpendicular slope will be negative 2/3, right? So I could give you a different example. Suppose I gave you a slope that was 7/10. What's the perpendicular slope to that? So that's something you can do. So what would it be? Maybe take a minute. It would be negative 10/7. I'm sure you are saying that out loud in the room that you're watching this, and whoever was outside the room may have thought you were strange. Negative 10/7. Anyways, okay. Question number 1. Complete the following table. So given the slope of the line 2/3, slope of all lines parallel to the given line, and slope of all lines perpendicular. So you may want to just take a moment and pause the video and fill these out, because I think you can do that. It's fairly straightforward exercise. So it's just the same for lines parallel, and it is the negative reciprocal for perpendicular lines. So maybe just take a moment, pause the video, do that, and I'll just quickly fill out these as well. So you can resume the video, I guess, when you're wanting to check your results. Okay, 2/1 is the same as 2. So 2, and the negative reciprocal of 2 is negative 1/2. Okay, and then that would be negative 5, that would be 0, that would be undefined. So negative 5, same as negative 5/1, so that would be 1/5 if we wanted a perpendicular line. 0, so that would be a horizontal line. If we wanted a vertical line, which would be perpendicular to a horizontal one, we would need undefined. And a vertical line perpendicular to that is a horizontal, and the slope of a horizontal line is 0. If you find it maybe somewhat easier, you can think of this as like some number divided by 0, and then, that would be, so 0 divided by some number. So the rise is 0, the run is whatever you like. It doesn't matter what this a will be. So you could just say a is a real number. It could be 1, 100, whatever you like. Okay, and then if we take the inverse reciprocal of 0 over some constant a, the negative reciprocal of that would be negative a over 0, and if you divide by 0, it's just undefined. And it's kind of just the opposite for that last row. So there you go. All right, question number 2. Draw a line passing through point A at negative 4,2 that is parallel to the line passing through BC. So negative 4,2, let's maybe just locate that first. So negative 4,2, that's where A lives. I guess we might as well locate B and C as well. So negative 2, 1, that's where B lives, and 5, 4, that's where C lives. So this line we have, let's maybe just draw a line there. Here we go. So if you have the tools, I guess you could just take that and move it like there. So that's what we need, but let's maybe just try to be a little bit more precise with that. It would be probably good to figure out what the slope of BC is. So let's maybe go ahead and do that. So just in the space below here, m of BC, so the slope of BC is, we'll do y2 minus y1 over x2 minus x1. So I'll use x2, y2 to be point C, so that's the 5, 4 thing. And that'll be your x1, y1. So it'll be negative 2, 1. So we go 4 subtract 1 over 5 subtract negative 2. 4 subtract 1 is 3, 5 subtract negative 2 is 7, so 3/7. We need, so any line that is parallel to BC will have a slope of 3/7, so the rise is 3, the run is 7, so if I start at A, the rise needs to be 3 and the run needs to be 7, so from here, if I go up 3 and to the right 7, 1, 2, 3, 4, 5, 6, 7, that will be my next point. So I'd have 3, 5. And now we can draw a line. So we need something going through A and 3, 5. So you maybe just grab a ruler, draw a line from A to 3, 5, and that's what we're looking for. Okay, if you want, you can maybe just pause the video and try number 3 on your own. I think you could probably do it, but we'll go through it together right now as well. So let's start by locating A. So that's at 3, negative 2. That's where A lives. We need something perpendicular to this BC. So B is negative 2, negative 2, negative 3. That's B. And 0, 3 would be, this kind of crazy line here is a bit off. So, okay, well, that's the origin line, right? That would be where C is exactly, 0, 3. And this is negative 2, negative 3. So let's just maybe draw a line there. So we need something kind of looking roughly like that. I guess I could adjust that somewhat. So roughly, that's kind of what I'm looking for. But I need to be a little bit more precise than that. So it'd be helpful to start by figuring out the slope of BC. So let's do that. Slope of BC this time will be 3 subtract negative 3 divided by 0 subtract negative 2. So that's again y2 minus y1 over x2 minus x1. 3 subtract negative 3 is like 3 plus 3, which is 6. And 0 subtract negative 2 is positive 2. So 6 over 2 is 3 over 1. And if we want something that is perpendicular to that line, so a line perpendicular to BC has a slope of what? Negative 1/3. So we flip the fraction and put a negative in front of it. So the slope should be negative 1/3 if we're wanting it to be perpendicular. Okay, so on the grid, my rise would be negative 1 and my run would be 3. So negative 1, 1, 2, oh, so we're off the grid, so it's roughly in that area, but I'd like to be a little bit more precise than that. So maybe let's just work the opposite direction. So if we're going down 1, right 3 each time, we can figure out where the previous point came from by going left 3, up 1. So that would be another point, and then we go left 3, up 1 again, and so on. And that's our line. So we can connect these points. So that's our line, and these BC is perpendicular to A. I don't know, I guess we could call it D, DA. So those two lines are perpendicular. Okay, moving on. Number 4, the slope of L1 is k over 8, and the slope of L2 is 3 over 4. Determine the value of k if L1 and L2 are parallel. So if they're parallel, M1 needs to be equal to M2. So if we start with that, M1 equals M2. So this is M1, k over 8, and M2 is 3 over 4, so they're equal. And we have an equation here for k, and we just need to solve for k. So we can multiply both sides of this equation by 4. So let's maybe just do that in a different color. So multiply 4, that gets rid of the 4 in the denominator on the right side. So we have 4k over 8. So 4k over 8 equals 3. And so we can do 4 over 8 reduces to 1/2. So k over 2 equals 3. And then finally, I guess I can just multiply both sides by 2 to get rid of the denominator on the left side. So 2 divided by itself on the left is just 1. So k remains. And 3 times 2 is 6. So the value of k should be 6. And I guess we can check that. So let's see. M1 equals 6 over 8, which reduces to 3 over 4. And that's the same as the other slope, so that's great. Okay. Similar idea for number 5. Feel free, obviously, to just pause the video for a bit if you want to try this on your own. I think you can probably do this one, and you could probably make a reasonable go at that one as well. But we'll go through it together right now. So the slope of L1 is 5 over k, L2 is 4 over 3. Determine the value of k if L1 and L2 are first parallel. So parallel, we have M1 equals M2. 5 over k equals 4 over 3. If I multiply both sides by 3, I get 15 over k equals 4. And then I can multiply both sides by k, so I get 15 equals 4k. Divide both sides by 4, so I get k equals 15 over 4. So we can check that. So if I put 15 over 4 in for k, so let's just do a quick check. So 5 divided by 15 over 4 is the same as 5 over 1 times 4 over 15. So that's 5 times 4 is 20. 1 times 15 is 15. 20 over 15 reduces to 4/3, and that corresponds with the slope of L2. So that's what we were after. Okay. The next one, if we were looking for the lines to be perpendicular, slightly different approach here. We need M1 to be equal to the negative of 1 over M2. So that just does the reciprocal version. So like, for example, so suppose you wanted to do the reciprocal of 3 over 4. You can try like I guess if you want, typing it into your calculator, 1 divided by, and then like 3 over 4, that would give you 4 over 3. So putting this in the denominator, so 1 over that thing just makes it so the reciprocal of, so it takes the reciprocal of m2. Okay. All right, so this should work. 5 over k equals negative 1 over 4/3. Okay, 5 over k is going to be then negative 3 over 4. And so multiply both sides by 4, we get 20. Multiply both sides by k, we get negative 3k. So k will then be negative 20 over 3. And we should check this, so maybe I'll just do this in a different pen because it's getting a little crowded. So put negative 20 over 3 in for k. So 5 divided by, check, 5 divided by negative 20 over 3. And when we evaluate this, it should turn out to be negative 3 over 4. So, okay, 5 over 1 times negative 3 over 20. 5 times negative 3, negative 15. 1 times 20 is 20. That reduces to negative 3 over 4, which is the inverse, sorry, I keep saying, the reciprocal, the negative reciprocal of 4/3. Okay, nearly done. We're just going to go over 6 and 7 here. Okay, so determine the value of y if we've got a, b, and c. We need AB to be perpendicular to BC. So they need to be the negative reciprocal of each other. So like for example, if I found the slope of AB worked out to be like 2 over 1, then the slope of BC should be the negative reciprocal of that, which is negative 1/2. Okay, and then obviously if I do the negative reciprocal of that, it's 2 over 1, and then the negative's gone. So that works. So let's figure out what the slope of AB is first. So let's go ahead and do that. So we're going to use our formula y2 minus y1 over x2 minus x1. So we're using that a lot today. Negative 4. So negative 4 subtract 2 divided by, what do we got here? 2 subtract 5. Negative 4 subtract 2, negative 6. 2 subtract 5, negative 3. So that works out to be just 2. So we need the slope of BC needs to be negative 1/2 because that's perpendicular to 2 over 1, right? So the expression for the slope of BC would be y minus negative 4 divided by 8 subtract 2. Okay, and we need to solve for y. We have what m of BC is, so we just plug that in, negative 1/2. The top of this simplifies to y plus 4, and the bottom of this simplifies to just 6. 8 subtract 2 is 6. I can, if you like, multiply both sides by 6. So I'd have negative 6 over 2 equals y plus 4. So we get that. So multiplying both sides by 6 got rid of the 6 on the denominator here. So maybe I'll just write that out. So times 6 times 6. So 6 divided by itself is 1, so we're left with y plus 4 on the right. And negative 6 over 2, we can simplify that a little bit to be negative 3, y plus 4. So subtract 4 from both sides, y is negative 7. Okay, and we can obviously check that by subbing, I can sub this in for y and just forget the fact that we've done this. So if I sub negative 7 in here and evaluate this expression, it should give me negative 1/2. Okay, and so you may want to try that just on your own, but it should work. Okay, one more question we'll do together, and then I'll give you a couple to try out on your own. So if the triangle has vertices located at P, Q, and R, prove that PQR is a right triangle. So it might be a good idea to just roughly sketch these points on the coordinate plane. So W would be like, oh, sorry, hang on. We've got P, Q, and R, rather. So P would probably be roughly here. There's P. Q would be kind of roughly, that's Q. And R would be kind of far over here, and like that. So I probably won't need to compare PR and QR because I don't expect these two lines to be right perpendicular. So roughly speaking, right, that doesn't really look like that would give us a 90 degree. So maybe skip that one, and I'd probably I'd probably check this one. So let's see if that works out. So if I compare the slope of PQ to the slope of QR, we should find that they are related somehow. So the slope of PQ, so I do y2 minus y1, x2 minus x1, so that'll be, let's see here, negative 3 subtract 2 divided by 1 subtract negative 3, so 1 subtract negative 3. The top of that will be negative 5, and the bottom will be 1 plus 3, which is 4. Okay, so if this is a right angle triangle, I would expect the slope of QR to be 4/5. So that's the negative reciprocal of that slope, right? That tells me this line is perpendicular to that one. So let's figure out the slope of QR. So we'd go 5 subtract negative 3 divided by 11 subtract 1, 11 subtract 1, 5 subtract negative 3 is 8, 11 subtract 1 is 10, 8 over 10 reduces to 4/5. So that is consistent with my expectations. So these are perpendicular. So because those are, hopefully you can still see that, because those are perpendicular, that means they're 90 degrees. So that means that this one is a right angle, and I got 3 points connected, that's a triangle. So PQR should be a right angle triangle. So PQR is a right angle triangle. Alright, I'm going to leave number 8 for you to do on your own. So I've given you a bit of a hint here, so you can pause the video if you want to take a closer look at this. W, X, and Y. You'll probably need to see if some of these lines are perpendicular, if it's going to be a right angle. So quite similar to question number 7 that we just did. And I'll get you to do number 9 on your own as well. Again, I've given you a little bit of a hint here, so you can pause the video if you want to have a closer look at that. So you just need to figure out, is that parallel to that, and is that parallel to that? So if that's the case, if AB is parallel to CD and also BD is parallel to AC, then it is in fact a parallelogram. So the question there is the quadrilateral a parallelogram? So those are the conditions. You need both this parallel to that and this parallel to that. If it's only the case that there is one parallel to the other, and maybe these two are not parallel, then it is not a parallelogram. It would be something else. Okay, so summary. The slopes of two parallel lines are, you could probably get this, equal, and the slopes of two lines that are perpendicular are negative reciprocals. Okay, so that's it for me for today. I will just get you to send in your submissions for number 8 and number 9 when you have those done, and I'll see you next time.